All right, guys. So the second part of section 1.1 is to talk about graphs. You have been learning how to make a pie chart and a bar graph forever, probably since fourth grade, third grade you first started. Today, what I want to do is I want to walk you through some good ones and some bad ones. All right, you know how to make them. So here we go. This is one I found. All right, surface type sector labels. If you take a look. All right. Oh, the menu keeps popping up. I apologize. So when we look, oh, no, go back. So, all right. This one is not really bad. Okay. They gave a title at the top. They didn't have too many wedges. If you look, they gave us, I believe these are percentages or 30, 18. If they are percentages, then that's a problem. I don't believe this is going to add up to 100%. Maybe I'm wrong. It might, but it's not really. So this is okay. If it does add up to 100%, then it's good. If it doesn't add up to 100%, then we have problems. The proportions look about right. This looks a little more than a quarter. It's 30. If that's 30%, then you're good. And I'm okay with that. All right. This one is absolutely atrocious. Okay. Oh my gosh. I would imagine this is population by state for the United States. So that means we have 50, maybe 51. I think Puerto Rico's in here. Yep. So Puerto Rico's in here. You got probably Washington, D.C. Look, California, good. Look at this up here. This is just nonsense. They just say other 16 million and they clump all of these states together without anything. And there's no title. I know you've been learning since you were a little kid about making a title, but you have to make a title. That's beyond important to include a title or a key or a legend to your graph so you know what you're doing. Okay, so this is a big no-no. You should never, nope, no, absolutely not. This one is a no. There is not one number on this graph. Not one. You have to have a number. You have to have an axis, or like a pie graph won't have an axis, but you have to have numbers. Terrible, 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 terrible. Okay, don't do that. This one, all right, is also terrible. Can you figure out why it's terrible? All right. It's terrible because do you notice that this 32% is the same size as this 4%? Right? And if you think about it, here should be a quarter. Well, we know that a quarter of your graph is definitely more than 32% of your graph. So this 32 should really be this entire space. 4 and 1, 1% of a pie chart is a sliver. Like there isn't even like room for color. Okay. So this example of a terrible graph. This one, as delicious as it looks, is also terrible. Why? Okay. Why is this terrible? So this one's terrible because it's too much. This is more than 100% right here. Apple, pumpkin, and chocolate cream. Pumpkin pie is my favorite. Okay. But apple, pumpkin pie, and chocolate cream. This is already 100%, over 100%. So what happens is this person, when they collected their data, they said, what are your 3 most favorite types of pie? And 3 most favorite types of pie is not okay to use as a pie graph. It's fine to collect data like that, but it's not okay then to put it in a pie chart because a pie chart should only be, get it? It's a pie chart of pie. But a pie chart should only be 100%, exactly on the nose every time, 100%. All right, here's one that's also interesting. Okay. What happens when you make graphs like this, and the media loves this kind of graph. So what happens when you make a graph like this is that the width of each item needs to be the same. So do you see how Starbucks and Taco Bell are about the same width? But then Pizza Hut at least appears to be more narrow than KFC just based on the colors. Really, this needs to be bars. If you have a bar here, Pizza Hut and KFC are essentially the same height, but KFC just looks bigger because they used a 2D shape. Wendy's looks even bigger because they used, like, it's a different shape. Burger King circles, right, height-wise, you just want a bar. McDonald's, do you notice? Yes, McDonald's is tall, right? 41 billion in sales. But do you also notice that McDonald's is so wide? right? It's so wide that it's not an accurate representation. If you use just the same bar width, if this right here was a bar, and then you did the same size bar here for Burger King and the same size bar here for Wendy's, you wouldn't go up and out. You wouldn't have this 2D making McDonald's look that much bigger. Also, I have no idea why they would do the GDP of Afghanistan behind it. Okay. You should keep your graphs, of course, consistent. The title, what year was this collected in? I have no idea. Was this for a quarter? Was this for a year? Was this for half a year? Like, where was it? All right. Here's another one. Terrible. Okay. Terrible because this was last year. This was last week. This is current. So this was a 1 week time span, and this is a 51 week time span. So this growth happened over 51 weeks, and then this growth happened over 7 days. No, this has to be consistent. A good graph and a good job of doing this would have 52 weeks, and you could see what happens in here. This looks really steep, but over a year, it's not that steep. All right. It might be that this increment change was consistent week to week to week to week to week for the first 51 weeks of the year. Oh, that's blurry. I apologize. But if we use this basketball idea, okay, the same idea as the McDonald's example. This basketball, the color is dark and this one is light. So this one looks bigger, but really they're almost the same size. Okay. And when you're looking at height, once you increase the radius of a circle, go back to geometry a little bit. When you double the radius, you're quadrupling the area. So the surface area of this is so much bigger than the surface area of this versus the surface area of this. These should be bars. Absolutely bars. You're not allowed to use circles to represent something that should be a bar. Okay. Here's another one. Okay. This was average female height per county. All right, let me just get rid of this. Okay. Nope. I'll go back. All right. So here's one where it's average height, female height per county. But what's happening is, and they have the countries down at the bottom, what's happening is they're increasing the width at the same time as they increase the height for proportionality. So yes, this one's shorter, but it's also narrower. Okay. These three are pretty much the same, but the dark colors stand out differently than the light colors. Again, they should all be bars. Okay, here's one. And you can notice it's a picture that someone took on their TV. It's actually a statistics teacher that I follow, like this group. You know, I'm on a group and they took a picture and oh my goodness, ready? So again, notice it's biggest COVID-19 worries, family getting it 62%, getting it 48%, the economy 68%. We have more than 100%. We have almost 200%. Okay. Not okay. Because it was probably like, what are your biggest worries? And people could select more than one. If you can select more than one, you can't use a pie chart. All right. This guy, ooh, terrible. Why is it terrible? All right. It's increasing by day. June 17, 18, 19, 20, 21. We've got a good title. Florida confirmed cases. But notice we have 3,200, 3,800, 4,000. Oh, up here is 2,900, which is way higher than 4,000. No, terrible. Absolutely awful. Okay. This guy, I don't even really know how to read. And this is my job, right? So the dates are all over the place. This keeps showing up at the bottom. Stop it. Notice, like you got May 9, May 8, May 3, April 26, May 7, May 2. It's not going in order, okay? The other things are that it's in the top, it's saying the chart below represents the most impacted counties over the past 15 days and the number of cases over time. So how are you doing the number of cases over time and the number of in the past 15 days? In addition, they're also saying the table below also represents the number of deaths and hospitalizations in each of those counties. Well, deaths and hospitalizations are completely different numbers. So are we talking about like this Hall County being over 150? Is it 148 were in the hospital and 2 died? Or was it 100 in the hospital and 50 died? You can't group them like that. That just, it literally doesn't make any sense to me. You can't put something like that together in one bar. You can put them together in one chart, maybe do blue and then blue striped, do orange and orange striped, yellow and yellow striped to represent the two comparisons, which absolutely that's important. That's going to be part of our lesson today. But to do it this way, oh my gosh, no, you can't just lump together two drastically different topics in the same bar. And now you can see at the bottom, look at this axis. It is not chronological, which just makes my head hurt. Okay. I think, and then this guy, and my sister lives in Georgia. She actually sent this to me. What's wrong with this? Okay, same map. Okay, notice the same counties are in red. Okay, they're the easiest ones to pick out. The same counties are in red as the highest. They both measure in cases per 100K. However, do you notice that the intervals have changed in 3 days? So on July 19th, to be a red county was in this range. But on July 22nd, if you have 3302 on July 22nd, now you're in the blue because there was a higher group in the red. These graphs should not be, you should keep a consistent axis, or it's not an axis, but your category grouping needs to remain consistent because they're not comparable. If you wind up changing as the time goes on and you need to increase the max, then you really should go back and regraph this with the same category grouping or the same boundaries for your groups so that you can graph them properly, okay? Because you need to keep it in a consistent fashion. All right, here's another guy, right? If you look just at graph 1, you're like, oh, people like hot dogs, people don't like hamburgers, right? But notice the axis started at 950. This is not okay. You always need to start your axis at 0, okay? You always have to start at 0 because when you start at 0 and you draw it accurately with your bars going up to where they belong, starting at 0, it's pretty much a tie. So if you're planning Carnival Day and we're buying food for everybody at Seneca, all 1,200 students, I would buy equal, right? I'd buy the equal things. Whereas if it was here, all right, then you would have been buying way more hot dogs than hamburgers. But the truth is that when you use the proper axis, they're pretty much the same. So that is that. All right, we'll talk about these in class too.